All right, so here we go. A little bit about units. As most of you have been introduced to, the metric system is what we use in science. And what makes the metric system so neat is that for every measurement there is a base unit, and then we modify that base unit by a series of standard prefixes. And as long as you know the prefixes, you can make sense out of um, the system. So if you need a small unit, you'll put a prefix that makes the base unit smaller. If you have a big uh, thing you're measuring, you use a prefix that makes it bigger. So for example, let's talk about distance. Okay, when you're measuring distance, I think everybody knows that the unit in the metric system for distance is the meter. Okay, and its abbreviation, again, as I think you all know, is a lowercase m. All right, so if I want to measure a long distance, like I'm going to take a hike in the woods, I might choose to use the prefix kilo, which, again, most of you probably know is equal to 1,000, or as we try to emphasize in AP Chemistry, 10 raised to the third power. We like working with powers of 10. So 10 raised to the third power is equivalent to 1,000, which is equivalent to the prefix kilo, which again has a one-letter designation of K. So we can talk about kilometers, or to be more shorthand, km. Okay. On the other hand, if I'm measuring a short distance, like the distance between atoms, I might talk about nanometers. Now, nano means 1 billionth. 3, 4, 5, 6, 7, 8, 9. That's a billion. 1 over a billion is a nano. And again, this really illustrates how nice the power of 10 thing is, because a billionth is 10 to the minus ninth power. Or again, if we wrote that in non-scientific notation, we would write that as 0.00000000001. Okay, so that's nano. Okay, but again, emphasizing the fact that the powers of 10 are really important to us. And a nanometer is just written like that. Okay, nanometer. Okay, so a nanometer would be a unit that you would use for a really small, tiny distance. Okay, now in chemistry, we work with big measurements and small measurements. So we need a nice system to be able to do that. Now think about the English system. You know, we measure, if we have very short distances, we might use inches or fractions of an inch. If we have long distances, we might use things like yards or miles or things like that. But there's no real standard relationship between those. Let's think about it. 12 inches in a foot, 3 feet to a yard, 5,280 feet to a mile, et cetera, et cetera. It's really a system that's really pretty awkward. So it's not surprising that the United States is one of the few countries in the world that actually uses the metric system. So now, one of the challenges is making conversions between the metric system. It's a good way to understand the metric system and the prefixes, and it's also a good way to practice a type of problem solving that we call the dimensional analysis, or factor label method of problem solving. And again, you've all seen this method before, okay, for problem solving. Your teachers have taught this to you here at Vistamar, and probably back in your middle school days. But in AP Chemistry, we really want to emphasize it. And the dimensional analysis approach, or factor labeling method, really focuses on the unit. I'm going to change color here. Let's see. Focus on the unit. Okay. Unit focus. Okay. We actually use units to help guide our problem solving. So let's do a sample problem. For example, suppose I wanted to know how many. Excuse me. Let me jumping ahead of myself here. Okay. So I'll write a question. Suppose that somebody poses a question. How many kilometers are in 15.6 nanometers. Okay, there's a basic sort of question. You've seen questions like these at the end of the chapter. We've worked some of these at the beginning of the year. Again, first step in the problem solving is to rewrite the question. How many kilometers are in 15.6 nanometers? And again, as I've emphasized in class, I can't say enough about the fact that this is the most important step. To take the words, okay, and you're going to be seeing lots of words problems, and to try to take that word expression and put it into sort of a mathematical expression, where on the left-hand side, you start with the question mark. The question mark is, what am I going to find? I want to know how many kilometers are in 15.6 nanometers. Okay. Now your trick is to say, okay, I now need to figure out a series of factors or conversion factors that will allow me to get from nanometers to kilometers. Okay. First thing you might want to think about, you might say nano. Well, I remember nano is a small unit, so nanometers are very small. Kilometers, on the other hand, are very large. So I'm predicting that my answer is going to be very small. Kilometer is a unit for something big, and I am trying to use it to talk about something very small, nanometers. Okay, so key here, always go back through the base unit. Okay, this allows you to use your definitions. It doesn't force you to do things inside your head. So, for example, you come along here, and very simply, oops, I'm having a problem here when I click my button. Oh, darn. Here we go. Let's see if I can undo here a little bit. Johnny, undo. Okay, let's try that again. So I want a conversion factor, and again, a conversion factor is just the ratio. I want a conversion factor. I definitely know I want nanometers in the numerator. And again, why do I want nanometers in the numerator? Because I know I want the units to cancel. Key to the factor label method or dimensional analysis method is for units to cancel. Now, in the top, I'm going to use the definition of nano. Nano means 10 to the minus 9th. So where I had nano here, now I substitute 10 to the minus 9th in the top, and I'm just going to put meters there. So a nanometer is equivalent to 10 to the minus 9th meters. Nanometers cancel, no calculation yet, because at this point, I have meters. I'm not finished the problem. Next, come along and say, okay, I'm going to put meters on the bottom. I can put kilometers now on the top because I'm back to the base unit. Okay, I can use my definitions. I know I want to go to kilometers, and then I use my definition. A kilometer is 1,000 meters. Okay, so again, I'm substituting the numerical equivalent for the one-letter prefix. K equals 10 to the third, or 1,000. Meters cancel meters, and now I'm done the problem solution. Now, the trivial part of doing the calculation, then my hope is that you can do some of these power of 10 calculations in your head. Now I know that what I do to get the solution is to take 15.6 times 10 to the minus 9th divided by 10 to the third. We're using my powers of 10. I know that 10 to the minus 9th divided by 10 to the third. When I divide powers of 10, I subtract exponents. So this is going to be 15.6 times 10 to the minus 9 minus 3, which is going to be 10 to the minus 12 kilometers. And then to put it into standard scientific notation, I'm going to say 1.56 times 10, which is the same as 15.6 times 10 to the minus 12, or my answer is going to be 1.56 times 10 to the minus 11 kilometers. And the answer feels good to me because it is an incredibly small number, and that means there's going to be a tiny, tiny number of kilometers in that 15.6 nanometers. Good. Okay, thus ends the first lesson.